Okay, for number one, find the Taylor polynomial T3, centered at x equals 0 for the function. It's a rational function, 2 divided by 3 plus 3x. You know the whiteboard to do it. And let me just expand this a little bit and write down the function again. So the function is, this is number one again, f of x equals, it's 2, and then you get 3 plus 3x, right? So in the future, these will be easier to do, but right now, let's just go through the process that we want you to go through. You're going to need to take repeated derivatives, so I'm just going to rewrite this so it's easier for me to take a derivative of it. This would be 2 over 3, and then that would be, well, maybe I'm going too fast by doing that, times 1 over 1 plus x. And then I'd write this as 2/3, 1 plus x to the minus 1. Start taking derivatives, all right? So f prime, what does it give you? Minus 2/3, 1 plus x. Well, let's see, I got to decrease it by 1, so minus 2 now, right? Relatively simple to do. F double prime. Well, I'm still going to write down minus 2/3, by the way. And then I can write down minus 2, 1 plus x to the minus 3. Right, got another derivative down. And you could do this all day long, by the way, but the point is you don't want to do it all day long. Someone says, how long do you need to go? Well, remember when you read the question, I want you to put down, I believe I have to look at the question again. It was T3. So we're almost there. So let's put this down. So it's minus 3, and then 1 plus x to the minus 4. They want this thing centered at 0, so I'm going to set x to equal 0 now. That's the center of it. So f of 0 is going to be 2/3. F prime of 0, let's take a look at that. It's minus 2/3. F triple prime, I'm sorry, not triple prime, F double prime of 0 is going to be, let's be careful about this. It's going to be 4/3. And now let's do F triple prime of 0. What does that give you? Let's see, you get 4 minus 12/3, which is minus 4. Whoops, I'll doohickey there, get rid of it. All right, so I think I'm ready to write down the results of this now. And how do you do that? Well, let's write it down. So f of x is equal to 2 over 3 plus 3x. And what they want me to do is write down T3. Well, let me write that down. It's going to be f of 0 over 0 factorial, and then x minus 0 to the 0, plus, and we'll figure this out, f prime of 0 over 1 factorial, x minus 0 to the 1. And again, over time, this will be much quicker. F double prime of 0 over 2 factorial, x minus 0 squared, plus f triple prime of 0 over 3 factorial, x minus 0 cubed. Let's write it down. So T3, we'll make it nice and neat too, put a box on it. What was f of 0? Let's go back over here. It was 2/3. What's 0 factorial? 1. And x minus 0 is going to be 1. I got the first term. Let's go to the next term. What's f prime of 0? It's minus 2/3. We're going to divide by 1 factorial, which is 1, and raise x minus 0 to the first power, so x. Let's go to the next guy, f double prime of 0. Well, that's 4/3, but I'm dividing by 2 factorial, which is 2, so it'd be plus 2/3. And that's going to be x squared now. F triple prime is minus 4, but I'm dividing by 3 factorial. So minus 4, and 3 factorial is 3, 2, 1. So what are you going to get? You get minus 2/3. And then what do you get there? X cubed, all right? This is what they asked for. That's what you're going to give them, all right? I want to suggest there's another way of getting it. Right now, I wouldn't be so concerned about getting it multiple ways, but this is the way that we're teaching it at this point, all right? But anyway, T3, let's just check the K, but I will go through another method. 2/3 minus 2/3 of an X plus 2/3 of an X squared minus 2/3 of an X cubed. I want to go through one other method of getting it, all right? So what do you get? You have f of x equals 2/3 times 1 over 1 plus x. What I'm going to suggest to do is by long division. So what do you get? 2/3, and now we're going to long divide. I know it seems difficult, but we're going to divide 1 plus x into 1. Well, it goes in one time. What do you get there? 1 plus x. What do you do now? Subtract. You get minus x. That would be minus x. What does that give you? Minus x squared. Subtract, you get x squared. What do you get there? That's going to be plus x squared. What does this give you? X squared plus x cubed. What do you get there? Minus x cubed. And this goes on and on and on. What I'm going to do now, minus x cubed. You could do this forever, but it's a nice pattern to it. You may recognize the pattern from what you learned in Math 120, which is the pre-calculus. Keep going, but I think I got enough there. Let's write this down. So I'll write it as 1 minus x plus x squared minus x cubed. I think I know the pattern for it, by the way. If I kept writing this down, what would the next term be? Well, it looks like plus minus plus minus. I'm going to say x4, then minus x5, and then I'm going to say plus yada, yada, yada. But they didn't ask for that. What they asked for, they asked for the Taylor polynomial. Let's go through that. We have my eraser out. Erase this long division. I'm done with it. And you'll certainly see me do more of that. So what's that? What's T3? Well, it's 2/3. And then I'm just going to take these terms over here. What do you get? 1 minus x plus x squared minus x cubed. I'm going to multiply it out. That gives me 2/3 minus 2/3 of an x plus 2/3 of an x squared minus 2/3 of an x cubed. That's T3. Again, are we matching what the key says? Yes, we're matching what the key says. Are there other ways of doing it? There are. Let me just talk about that other way, all right? One thing you should know is that 1 over 1 minus x is the same thing as 1 plus x squared. You learned this in Math 120. It's a geometric series. From that, you should be able to generate 1 plus, whoops, didn't mean to put that down. 1 over 1 plus x, and why is that? Well, it looks like the above one, with exception. It's really like this over here, with the understanding that now x is minus x. What do you get? 1 minus x plus x squared minus x cubed, yada, yada, yada. You could generate it that way as well. Are you getting the same results? You're getting the same results every time. Here's the key, though. To do these problems, we are going to recommend that you follow as instructed initially, and that is taking derivatives, evaluating the derivatives at where it's centered, and following the pattern for the Taylor polynomials. Whether they're centered at 0 or some other number, we need to follow that pattern. Thank you.